we consider an example of a position versus time graph, and we'd like to know a number of different pieces of information about this graph. So we'd like to know for part A, during approximately what time interval is the object moving at a constant speed? When is it speeding up? When is it slowing down? During approximately what time interval is it moving in the positive direction? When is it moving in the negative direction? At what times does the object have zero velocity? Are there turnaround points? Because when there's a turnaround point, that also represents a position where the velocity is instantaneously zero. And then we also want to know what is the average velocity during certain time intervals. And so we're going to look at this in steps. And so let's go ahead to the next slide. So the first thing we can do when we look at the position versus time graph is try to break the graph up into segments where you can tell the slope of the graph and whether the slope of the graph is increasing, decreasing, constant, and positive, negative, and so on. If you have a position on the graph where there's a bump, that's basically the turnaround point. So we have a turnaround point up at the top, and we have a turnaround point at the bottom. So once we've identified the turnaround points, those are the positions where the velocity, instantaneously anyway, for a small amount of time is actually going to be zero. So we can break the graph up for sure at those turnaround points. We can also examine where we might see that the graph has a constant slope. And I notice in the very beginning here that the slope is relatively constant. And I also notice towards the end over here that the slope seems to be pretty constant. So I'm going to break this up again into sections. And so I've broken off a portion of the graph between 0 and 4 seconds where that slope of the graph is pretty constant. And so since the slope is constant, the velocity would also be constant here. And then I've done the same thing between 13 seconds and 15 seconds. I have a relatively constant slope here, seems to be a straight line, and so I would say the velocity is constant at that location. So I've identified the turnaround points and I've identified where the slope is constant and therefore the velocity is constant. Now, the nice thing about the turnaround points is that we know that when an object has an instantaneous velocity of 0, it has to slow down before the turnaround point. So in this region right here between 4 and 5.5 seconds, the object has to be slowing down. And also at the second turnaround point, before getting to that point there has to also be a situation where it's slowing down. After the turnaround point, the object has to speed up because it was initially 0 and now it's changed direction. And it's heading, in this example here on this side, is heading back towards the origin. And so it has to be speeding up in a certain region. So I've again broken this up into another section because I know that the second turnaround point, the object has to be slowing down before the turnaround point, but the first turnaround point, the object has to be speeding up afterwards. So the object is going to be speeding up between about 5.5 seconds and 8 seconds. But then also it's going to be speeding up by 10.5 seconds up to 13 seconds where the object has reached the turnaround point and now is heading back away from the origin. So we've got a number of different locations here in terms of an object speeding up, slowing down, and moving with a constant velocity. Anytime the slope of the graph, a position versus time graph, is positive, oops, I went a little too far there. When the slope is positive, that means the object is moving in the positive direction. So between 0 and the first turnaround point, 5.5 seconds, that's a positive slope and the object would be moving in the positive direction. And that's also true between 10.5 seconds all the way up to 15. That's a positive slope, and therefore that would be the positive direction. The object is moving in the negative direction between 5.5 seconds down to 10.5 seconds because the slope in that case is negative. So that's one way that we can think about this particular problem. Another way to look at it is to break your problem up into steps, and this has been done in the picture. So basically I've taken half-second intervals and I've gone from one point on the graph over 1/2 of a second and then up, and then over 1/2 of a second and up, and so on. And I can see that between 0, I'm going to go ahead and put the lines back in, between 0 and about 4 seconds, the steps essentially are equally spaced, and the slope is constant. Once I hit 4 seconds, the steepness of those steps is decreasing, right? They become less steep, and so the slope is decreasing and it's slowing down. And then on the other side of the turnaround point, the steps are getting more steep over time. Whoops. And then and therefore it's speeding up. And then again, the steps are getting less steep, slowing down until you get to the turnaround point, and then the steps are getting more steep, so it's speeding up. And then I get to a point where those steps are relatively the same steepness and they are constant. So that gives us an idea of another way that we can analyze the graph with these steps, but it's important that you keep the same horizontal distance for each of those steps, and then you can look at how the vertical distance changes. If we want to know what the average velocity is of an object between two different time intervals, the average velocity is just the final position minus the initial position over the final time minus the initial time. So here I would go to 0 seconds and I would go to 3 seconds on my graph. And so my final time is 3, my initial time is 0. My position at 3 seconds is 9 meters, and my position at 0 is going to be 0. So there's my final position, my final time, initial position, initial time, and I get 3 meters per second. And I could go over here and I could say, well, the amount I've moved between those 2 points is 9, which is my top number, and then along the horizontal is my 3 seconds. I can do the same thing between a time of 6 seconds and 9 seconds. So I can identify those points on the graph. So here's my 6 second mark and then my 9 second mark. When I'm at 6 seconds, my position at 6 seconds is, oh, that's written wrong. So that should be about 14 right there. That's 14. And then on the bottom at 9 seconds, I'm at about 4 meters. And so, yeah, this was a mistake on here when I was putting this in. So this should be 14. So 4 minus 14 is 10, and it's a negative 10. And then 9 seconds minus 6 seconds is 3 seconds. So that's how we can determine the average velocity. And this is negative because if you look between 6 seconds and 9 seconds, the object is moving in the negative direction, heading back towards the origin.